Good day, everyone, and I'm Anthony Jared Eljapsenko, and I will be presenting special purpose diodes. Let's start off with signal diodes. Signal diodes are nonlinear semiconductors. This device is utilized in applications involving high frequencies or small currents, such as digital logic circuits, radios, and televisions. Small signal diode electrical and electronic circuits consisting of semiconductor crystals are commonly referred to as signal diodes. The symbol for signal diodes are the standard diodes shown above. Next is the physical construction. It includes two layers, p-type and n-type. The N-type layer is separated into two regions like N-negative and N-positive, where one region is near the P-type material that is lightly doped and another layer is near the cathode contact, which is heavily doped. To prevent it from oxidizing, a glass or silicon oxide insulating layer surrounds the entire structure to protect it. Let's now go to the characteristic curve. When a positive supply is given to the anode and a negative supply is given to the cathode, it conducts current. If the voltage is supplied in the opposite direction, it stops all current flow. A signal diode should be able to entirely block a negative signal. Thus, it is anticipated that a signal diode will function flawlessly as a one-way valve for high-frequency electronic signals. Lastly, application for signal diodes. Signal diodes are best suitable for high frequency applications or switching applications involving short pulse waveforms. This includes radio, television, and etc. The next diode are the power diodes or rectifier diodes. Semiconductor diodes intended for rectification are called power diodes. This functions as one-way electrical valve because they are diodes. Large p-n junction areas are part of the design of the power diodes. They can now withstand high reverse voltage and high forward current thanks to this. A power diode can have a peak inverse voltage of kV or kilovolts and a typical forward current rating as high as Ka or kiloamperes. Worldwide, the main supply voltage varies by hundreds of voltage, usually between 120 and 230 volts. Such high voltage are within the design parameters of the power diodes. A power diode has the same electrical sign as a generic diode. Nonetheless, the symbols anode and cathode are effectively represented as A and K. Power diodes or rectifier diodes have the standard symbol. The cathode is composed of a strongly doped N-positive region. The strongly doped P-positive area is dispersed towards a mildly doped N-epitaxy. A high peak inverse voltage is the result of a high diode resistance. Silicon is typically used to make power diodes. They are also known as silicon power diodes for this reason. The holes from extensively doped P-positive region are injected into the lightly doped N-negative area of the power diode when it is forward biased. Because of its mild doping, the drift layer is unable to recombine all of the holes created. A power diode can withstand high reverse voltage under reverse bias because of its enormous current capacity and resistive structure. A power diode's reverse current, including reverse saturation current, is measured in hundreds of milliamperes. Some of the application of rectifier diodes are half-wave rectifier, full-wave rectifier, battery changing circuits, inverter circuits, flywheel diodes, DC power supply, and SMPS. Next is Schottky diodes. A diode is a device that has two terminals and a function as a one-way switch. The metal serves as the anode and the N-type semiconductor serves as the cathode in the Schottky metal semiconductor diode, which is renowned for having an extremely low forward voltage. An N-type semiconductor that has been mildly doped and a metal electrode are combined to create a Schottky diode. There is no depletion area in a Schottky diode because of the metal semiconductor junction. The device cannot function as a rectifier if the N-type material is not slightly doped. When a Schottky diode is forward biased, the current flows because of the majority of the charge carriers, that is, electrons. When a Schottky diode is constructed with a reverse bias, its host or minority charge carriers are absent. So, reverse saturation current conduction stops instantly. Next is the characteristical curve. The Schottky diode's nave voltage may appear lower under forward situation than that of a conventional PN junction diode. A typical PN junction diode has a forward voltage between zero point 0.3 and zero point 0.9 voltage. It may be observed that a Schottky diode conducts a substantially greater reverse saturation current in the reverse bias region. Minority charge carriers do not cause the reverse current in a Schottky diode. Rather, they merely contribute to the electron current. Some of these applications are general purpose rectifiers, solar cells, clamping, power or OR circuits, and SMPS, RF mixing and detection. Light emitting diode or LED. These are the most prevalent and prominent source of light found in electrical components. Light emitting diodes have a very distinct construction and structure. A transparent hemispheric shell body made of solid and plastic epoxy resin covers the PN junction, shielding the lead from vibrations, heat shock, and atmospheric disturbance. In order to safeguard the light emitting diode from excessive current flow, it must be linked in a forward biased configuration across the power supply and be current limited using a resistor connected in series. Since too much current will travel through the LED when connected directly to a battery or power source, the LED may be damaged. Next is laser diode. Compared to an LED, a laser diode is a typical type of semiconductor device. It emits coherent light or waves that are all at the same frequency and phase, using a PN junction. The laser diode uses a mechanism known as light amplification by stimulated emission of radiation, or simply laser. The current, milliamperes, flowing through the laser diode grows quickly with a slight increase in voltage. In the forward bias region where the anode is more positive than the cathode, the following graphics illustrates how at a specific threshold voltage the current increases dramatically, resulting in lasing activity and light emission. The threshold current arises at the current diode temperature arises. The N-type and P-type layers are sandwiched between metal plates that are attached to the input terminals. Another name for this kind of laser diode is a homojunction laser diode. In order to enhance the volume of the active zone and allow more holes and electrons to accumulate at the junction, the intrinsic region between the P-type and N-type materials is employed. Some of the applications are industrial application involving optical storage, instrumental field, telecommunication, medical field, defense deployment. Next are photodiodes. Photodiodes is a form of light sensors that converts light energy into electrical energy. Under reverse bias conditions, photodiodes functions. Plotting reverse current is done along the y-axis in microamperes, and plotting reverse voltage is done along the x-axis in volts. Reverse voltage has no bearing on reverse current. Reverse current is nearly zero in the absence of light irradiation. Dark current refers to the lowest possible current level. Reverse current increases linearly with an increase in light emulation. Photodiodes are also used in safety electronics like fire and smoke detectors. It is also used in TV units. When utilized in cameras, they act as photosensors. It is used in scintillators, charge coupled devices, photoconductors, and photomultiplier tubes. The PIN diode is an acronym for positive intrinsic negative. A PIN diode is a diode where the high resistivity intrinsic layer, or I, is positioned between the P and N semiconductor material layers. The intrinsic layer, which lies between these two layers, creates a strong electric field as a result of the motion of charge carriers like electrons and holes. The electric field direction in this case will be from N to the pin region.